and we're doing the Junior Engineering Clinic project for the fall of 2016. The project is speaker verification via sparse representation, and essentially the objective of this project is to prove that the facial recognition method of sparse representation is a more effective and more accurate method of facial recognition than the standard KNN classifier method. So to do this, we created and developed a KNN classifier through MATLAB as a simple baseline test to get a general knowledge of the identification success rate range. We did this using the AT&T database, which is a database consisting of 400 images. There are 40 test subjects, and each subject is made up of 10 images of the same person using different poses with different lighting. And what we did is we trained the database and tested images from the same AT&T database and analyzed the success rates and then optimized them with different DCT values and K values. After doing this, the further analysis is to create a sparse representation method and prove that the identification success rates are higher with this method instead. A few of the constraints we had to deal with were noisy images. So when speckled and salt and pepper noise was added to an image, how the identification success rates would change or drop a little bit. Some of the things we have to look for in the future are robustness to occlusion through sparse representation and also the choice of feature extraction. And some of the basic engineering standards that we followed in this project were using the standard sized and grayscale images and also following the basics standard algorithm for biometric systems where you enroll or train a database and then classify and test the testing images. So Eric is going to go over a little bit of the code we used.
So to perform the KNN classifier for facial recognition, we first have to take an image and turn it into a 2D DCT vector. So this file here, find features, reads an image, and then creates a one-dimensional DCT feature vector of length specified by TCT length. So when I run this file for an image in the AT&T database of length 55, it returns a feature vector seen here, one-dimensional. So now that we have the features found, we can then train the system. So we use this file here, which has an input of subject range, which determines how many subjects are in the database, and then DCT coefficient, which is the length of the DCT feature vector. So the file uses the first 5 images from each of the subjects and stores that feature vector in a matrix called tr data raw. So I'm going to go ahead and run that. For 40 subjects with a DCT length of 55. So once that is done, you can see in this tr data raw matrix that this is the trained database. It contains 200 feature vectors for the first 5 images from each of the 40 subjects. So once the database is trained, we can perform the actual facial recognition. So we have this final function that finds the correct subject for the test image for each of the test images, 6 to 10 for each subject, and returns the percentage of those images that were correctly matched. So after running this file, you can see that with a K value of 1, the percentage of subjects correctly identified was 92.5%. So messing around with different K values and different DCT lengths, we found that the highest percentage correct is 92.5% with a K value of 1 and a DCT length of 55. So Kevin's now going to explain how we dealt with noise.
Yeah, so after we optimized the KNN classifier with the DCT coefficient of 55 and a K value of 1. We went ahead and also analyzed the identification success rates after adding noise to the image. So as we add 25% salt and pepper noise to an image, we can see that the identification success rate drops slightly. And it drops to about 83%. As obviously this is still a good number, but with sparse representation, the method of facial recognition, we hope to see a higher number than 83%. The goal, as stated in the beginning, was to prove that sparse representation is a more accurate method of facial recognition. So hopefully, after implementing that method, we will see a higher percentage identification success rates than 83%.